Hi, this is GCSE 9 to 1 Crammers. It's never too late to start revising, and this way you can do it anywhere. Listen to these questions as many times as you need until the answers pop into your head. Today we're revising Chemistry Topic 1b, the trends of element groups, covering the trends of Group 1, Alkali metals, transition metals, Group 7, the Halogens, and Group 0, the noble gases. In the exam you'll be given a copy of the periodic table, so you don't have to learn all the names in each group. The group number will tell you how many atoms are in the last shell of an element. You also need to learn the physical properties, chemical properties and trends for Group 1, Group 7, Group 0 and transition metals. Learning the facts about each group will help you to predict reactions based on the position of elements in the periodic table, as well as comparing properties and trends and finding out if they're metals or non-metals. You need to think about all this stuff when answering any questions in chemistry. If the name of an element is given, always check the periodic table. Name the trends for each of the element groups. I use the acronym RAMD to remember them. All of the groups have the same trends, which makes it easy to compare them. R stands for reactivity, A stands for atomic number, M stands for melting and boiling points, and D stands for densities. You need to remember the trends and whether they increase going down the group or decrease going down the group. By learning the trends, you'll be able to predict reactions based on the position of elements in the periodic table. Why is it important to know how reactive an element in a group is? Because in chemical equations, the more reactive elements will displace or kick out less reactive elements. Knowing the trends in reactivity will help you understand how elements react with water, oxygen, metals and non-metals. Reactivity. In general, atoms are most stable and least reactive when their outer shell is full. For example, in Group 1 alkali metals, they have only one electron in their outer shell and are very reactive, whereas Group 0 noble gases have a full outer shell and are stable and inert, so they don't react. Why is it important to know the atomic number of an element in a group? The atomic number tells you how many protons there are in an atom, but it also tells you how many electrons an element has, and from that you can work out how many shells each element has. This will help to explain the reactivity of elements, like knowing how far the outer shells are from the nucleus, resulting in the electrons having a weak or strong attraction to the nucleus, and depending on that attraction, whether they lose or gain electrons. Why is it important to know the melting point of an element in a group? High melting points mean elements have strong forces holding them together and need a lot of energy to break them. Low melting points mean elements have weak forces holding them together and don't need a lot of energy to break them. Why is it important to know the density of an element in a group? Density of an element depends on how packed the particles are in the element. High densities, solids, particles are packed very closely together in fixed positions. Liquids, particles are close together but can move around. Low densities, gases, particles are spread out and free to move around. If you need to weigh out a certain mass of a liquid, it's useful to know the density, so you can calculate what volume to add. Separation. If you have two different liquids which won't mix together, you can also predict which one is which by the density. Name the trends for each of the element groups, Group 1 alkali metals. As you go down the group, reactivity increases, atomic number increases, melting points decrease, densities increase. Group 7, the halogens. As you go down the group, reactivity decreases, atomic number increases, melting points increase and densities increase. Group 0 noble gases. As you go down the group, reactivity decreases, atomic number increases, melting points increase, densities increase. Transition metals, as you go down the group, reactivity decreases, atomic number increases, melting points increase, and densities increase. Keep going over these trends until you know them well. State the trend in reactivity as you go down group 1 alkali metals. Reactivity increases going down the group. Describe and explain the trend in reactivity of the alkali metals. Alkali metals become more reactive as they go down the group, because the outer electrons get further away from the nucleus, so there is less attraction between them, and the outer electron is lost easily. State the trend in the relative atomic mass as you go down group 1 alkali metals. Relative atomic mass increases going down the group. State the trend in the melting and boiling points as you go down group 1 alkali metals. Melting and boiling points decrease going down the group. State the trend in the densities as you go down group 1 alkali metals. Densities increase going down the group. Do group 1 alkali metals have a low density or a high density? Alkali metals have a low density. What type of compounds do group 1 alkali metals form when they react with non-metals? Ionic compounds. Explain why group 1 alkali metals form ionic compounds with non-metals. Because alkali metals lose the one electron in its outer shell, forming a 1+ ion. Is it possible for alkali metals to form covalent bonds? No, because they never share electrons. How does potassium, an alkali metal, react with water? Potassium sizzles furiously across the surface of the water as hydrogen gas is released. How does lithium and sodium, alkali metals, react with water? They sizzle furiously across the surface of the water as hydrogen gas is released. Potassium is in group 1 of the periodic table. Potassium reacts with water in a similar way to lithium. Write down 4 differences you would see between the reactions of potassium and lithium with water. Potassium is more reactive than lithium. Potassium fizzes faster across the water than lithium. Potassium dissolves faster than lithium, and potassium produces a purple flame. What do alkali metals form when they react with water? A metal hydroxide and hydrogen gas. Write the general equation for this reaction. Alkali metal plus water produces metal hydroxide plus hydrogen gas. When lithium reacts with water, what gas does it produce? It produces hydrogen gas. When lithium, a group 1 metal, reacts with water, what type of solution does it produce? It produces an alkaline solution. Which ion causes the solution to be alkaline? Hydroxide. What do alkali metals form when they react with chlorine? A metal chloride. Write the general equation for this reaction. Alkali metal plus chlorine produces metal chloride. State the trend in reactivity of the transition metals. Transition metals become less reactive going down the group. Why does iron react with copper sulfate in this balanced equation? Iron plus copper sulfate produces iron sulfate plus copper. Iron is more reactive than copper, so it displaces the less reactive copper. State the trend in the relative atomic mass as you go down transition metals. The relative atomic mass increases going down the group. State the trend in melting and boiling points as you go down transition metals. Melting and boiling points increase going down the group. State the trend in densities as you go down transition metals. Densities increase going down the group. Explain why copper can be extracted from solutions of copper salts by adding iron. Iron is more reactive than copper, so copper is displaced. Compare the trends of Group 1 alkali metals with transition metals. Remember the acronym for trends, RAMD. R for reactive, A for the atomic number, M for melting points, and D for densities. Group 1 alkali metals are more reactive, whereas transition metals are less reactive. Alkali metals have low melting and boiling points, whereas transition metals have high melting and boiling points. Alkali metals have low densities, whereas transition metals have high densities. State the trend in reactivity of the Group 7 halogens. Group 7 halogens become less reactive, going down the group. Describe and explain the trend in reactivity. Group 7 halogens become less reactive as they go down the group because the outer electrons are closer to the nucleus, so the electrons have a stronger attraction to the nucleus and will gain an electron easier. State the trend in the relative atomic mass as you go down Group 7 halogens. The relative atomic mass increases going down the group. State the trend in melting and boiling points as you go down Group 7 halogens. Melting and boiling points increase going down the group. State the trend in densities as you go down Group 7 halogens. Densities increase going down the group because at room temperature fluorine and chlorine are a gas, which have low densities because their particles are spread out, while bromine is a liquid and iodine and astatine are a solid, which has a high density because their particles are packed closely together. What type of bonds do Group 7 halogens form when they react with another non-metal? Simple covalent bonds. Halogens can react with metals. What type of bonding exists in the compounds that are formed during these reactions? Ionic bonding. State the trend in reactivity of the Group 0 noble gases. Group 0 noble gases become less reactive going down the group. Why are Group 0 noble gases the least reactive and inert gases? Noble gases are the most stable and least reactive because they have a full outer shell. State the trend in relative atomic mass of the Group 0 noble gases. The relative atomic mass increases going down the group. State the trend in melting and boiling points of Group 0 noble gases. Melting and boiling points increase going down the group. State the trend in densities of Group 0 noble gases. Densities increase going down the group. Exam practice questions. When answering chemistry exam questions, always refer to your periodic table so you know the groups and trends for the elements in the questions. Name the products formed when chlorine solution reacts with potassium iodide solution and explain this reaction. The products formed are potassium chloride and iodine because chlorine is more reactive than iodine, so chlorine displaces iodine. Explain why the reactivity of the elements increases going down group 1 from lithium to rubidium, but decreases going down group 7 from fluorine to iodine. Group 1 metals easily lose the 1 electron in their outer shell because it's further away from the nucleus, therefore does not have a strong attraction, making them more reactive going down the group. Whereas group 7 halogens gain an electron easily in their outer shell because the electrons are closer to the nucleus and have a strong attraction, making them less reactive as they go down the group. What does potassium form when it reacts with water? Check the periodic table. Potassium is an alkali metal, and when it reacts with water, it forms potassium hydroxide and hydrogen gas. Boom! What does sodium form when it reacts with chlorine? Write the word equation. Sodium plus chlorine produces sodium chloride. Explain why chlorine is more reactive than iodine. Check the periodic table and you see they're from group 7. Think about the trends and you should know that halogens become less reactive as they go down the group. Therefore, chlorine is more reactive than iodine. Chlorine's outer electrons are closer to the nucleus. Chlorine's electrons have a stronger attraction to the nucleus and will gain an electron easier than iodine, which is less reactive, because its electrons are further away from the nucleus. Explain why iodine has a low melting point. Iodine is from group 7, which have low melting points because they're made up of simple covalent bonds, joined together by weak intermolecular forces which don't need a lot of energy to break. In this video you've learnt about the trends for alkali metals, halogens, noble gases and the transition metals, reactivity, atomic mass, melting and boiling points and densities. Take time to learn this topic so you can nail those exam questions in the Chemistry GCSE Paper 1. The key to exam success is learning, consolidation and keeping this topic fresh in your mind. How do you do that? Repetition, repetition and repetition. If you go over this enough times, you'll be able to answer any questions on this topic confidently in your exam. This is GCSE 9-1 Crammers, and if you like the content of this video, give us a thumbs up. And if you have a question or need help, give us a comment below and don't forget, smash that subscribe button if you want more Crammers videos for your exam success. Thanks for watching and see you again soon.